Good morning, students. Am I audible? Good morning, students. Am I audible?
Yes, ma'am.
Okay. So I'll start the class at 11:30. You tell your friends because there are only 10 participants. Total there are 38 students, I think, 35 or 38. So you tell them to join. Today we'll just go an introduction for this syllabus. Okay, so till 11:30 the meeting is unlocked. So you tell them to join. Okay, so this is your elective number 6. The subject code is PCCEL601. The name of the subject here is Engineering Risk and Uncertainty. It is a 3 credit subject, and there are basically many more objectives of this subject, but as the syllabus, as in this semester, we'll just study the basics. So I have cited only 2 objectives. The first one is, it is an introduction to probability and statistics. How it is an introduction? By introducing again the quantitative uncertainty analysis and risk management with emphasis on engineering applications. So in engineering, there, whenever we do any type of engineering work, basically when it comes to civil, there is always a risk and uncertainty factor. There is always a risk and uncertainty factor. For that reason, this subject is incorporated by the university according to the new AICT module. So here we'll see how the probability and statistics and how certain uncertainty analysis and risk assessment, how you will assess the different risk factors for engineering applications, on different engineering applications. Next, number 2 is to focus on probability theory and its applications. We have already learned earlier about probability. So here we'll study about the different theories of probability and its different applications. And this probability theory and applications covers the basic topics such as parameter estimation, hypothesis testing, and regression analysis. So under probability theory, the basic topics that we'll study here is hypothesis testing, regression analysis, and parameter estimation. So the objective of engineering risk and uncertainty subject is only that determining the uncertainty analysis and risk assessment in simple words. And the second one is determining or like analyzing the parameter estimation, hypothesis testing, and regression analysis. So after the completion of this subject, what are the outcomes? That means what, as a student, what you will understand or what you will learn after the completion of this subject. The first one is to formulate and solve problems dealing with probability and statistics in engineering applications. After the expected outcome is that when you'll at the end of the subject you will know and you'll also understand how you will solve or how you will formulate the different problems related to engineering risks and assessments. Number two is to employ sorry okay, number two is to employ the key concepts of probability, that is Bayesian inference and regression models to estimate uncertainty in engineering systems. So second one is we'll also understand how we will implement or how we will analyze or employ the basic concepts of probability, and also the Bayesian inference, which is a theorem or theory of probability, and regression models. So regression model is used to estimate the uncertainty in engineering systems. Next, number three is students, that is you all, will understand how to apply the different principles of decision making under uncertainties. Like when there is in an engineering field, when there is a situation where you are uncertain what will happen, so in that situation, how you will make your own decisions regarding the problem or regarding the risk. So you will also understand about the principles of basic decision making under the different uncertainty conditions. And the last one is applying risk management principles. Like under certain risk factors or certain risk situations, how you will manage the situation, how and by implementing what type of risk management principles. So these are the four expected outcomes at the end of the subject, or at the end of this elective subject, and the two objectives. Now there are total 5 modules: unit 1, 2, 3, 4, and 5. So unit 1 will be the topic is basic introduction and the basic risk methods. So here for unit 1 we'll have 10 lectures. Okay, so in introduction part there is engineering risk and uncertainty, knowledge and ignorance, like the basic knowledge of risk and uncertainty, and also how like many people ignore certain risk and uncertainties. All these things we'll discuss here. Then information uncertainty in engineering systems, the different uncertainties that will occur in engineering systems and the information related to that. Next, introduction and overview of class. Class is a basic definition that we'll study. Class doesn't mean the normal definition, but class means for the related thing, risk method, and uncertainty. Then, definition of engineering risk, which is obvious, we'll study it in the introduction part only. And then, overview of engineering risk analysis. As a whole, what are the certain risk analysis in engineering? We'll study about that. Then risk methods. So in risk methods, the first one is certain risk terminology. So under risk, there are certain definitions or terminologies. So we'll study about that. Then risk assessment, how we will assess or how we will calculate or analyze or define risk. Then risk management and control, how we will manage and control the different types of risk. Then risk acceptance, the acceptance of risk factor, and risk communication, that is communicating for different risk methods and identifying and structuring the engineering risk problem, like how we will identify definitely their engineering risk problem, how we'll identify it and how we will structure those problems and provide a proper solution of the same. Then developing a deterministic or parametric modeling. Sorry, developing a deterministic or parametric modeling, that is parametric model related to risk only. So how you will develop a parametric model and how you will like help in the proper risk control procedures. So this was your basic introduction and risk method introduction for unit 1. The topics are this. So lectures are total of 10. Next, for unit 2, the topic is system definition and structure and reliability assessment. So the total number of lectures is 7 here for unit number 2. So in system definition and structure, that is the first topic or heading. There we'll study about the different system definition models, then hierarchical definitions of systems, that is from ascending order to descending order. We'll study about the different definitions and parts and types of systems. Then system complexity, how a complex system can be worked on by using the different system definition models and structures. Next is reliability assessment. So in reliability assessment, we'll study about analytical reliability assessment. This is a type of assessment. So under reliability assessment, the first type is analytical reliability assessment. Then the second one is empirical reliability analysis using live data. So empirical reliability analysis using live data. And the third one is reliability analysis of systems. So the first one and the second one is, it is basically depends on the different systems, that is it is mechanical. And for the third one, which is empirical reliability analysis using live data, that will be based on using live examples. So we'll study about that also. And here in the unit 2, this is only 7 lecture. Number 3, unit 3. So lectures are total number of 5 lectures for unit 3. The first one is consequence assessment. So under consequence assessment, we'll study about the different types of the consequence, that is consequence assessment. Consequence means results. So how you'll get the result type of assessment. Then causes of consequence diagrams, cause consequence diagrams actually, and microeconomic modeling. Then value of human life, then flood damages and consequence propagation. So under assessment of consequence, we'll study about types, cause-consequence diagrams, microeconomic modeling, value of human life, flood damages, and consequence propagation. And under Unit 3, the subheading number 2 is Engineering Economics. And here we'll study about the time value of money, interest models, and equivalence. Under Engineering Economics, time value of money and interest models and equivalence. So unit 3 will be of total 5 lectures. Next, unit number 4 is decision analysis. And here a total of 5 lectures again. So under decision analysis, the first one is risk aversion. Second is risk homeostasis. Third, inference diagrams and decision trees, which is very important. Decision trees is a very important part of decision analysis. Then discounting procedures, decision criteria, trade-off analysis, repair and maintenance issues and maintainability analysis, repair analysis, warranty analysis, and insurance models. So these things or these headings or these topics will study under decision analysis, and unit 4 is a very important. Other units are also important, but we'll emphasize more on unit 4 in this course. The next one is unit number 5. The topic is data needs for risk studies. What type and what kind of data you will need to study different risks. So, under the data needs for risk studies, we'll study about elicitation methods of expert opinions and their guidance. Elicitation methods of expert opinions and their guidance. It is of 3 lectures, a total of 3 lectures. So, the number of lectures in total we'll have to do is 30. Total lectures is 30. So here I have cited total of 6 textbooks and reference books. The first one is Risk Analysis in Engineering and Economics by B.M. Ayub, Chapman Hall, CRC Press, 2003 edition. Number 2 is Bedford T. and Cook R. Probabilistic Risk Analysis, Foundations and Methods, New York Cambridge University Press, edition of 2001. Number 3 is Probabilistic Risk Assessment and Management for Engineers and Scientists by H. Kumamoto and E. J. Henley, which is the second edition of New York, 1996. The fourth is Normal Accidents, Living with High Risk Technology, C. Perro, Princeton University Press, 1999 edition. Then Probability, Statistics and Reliability for Engineers and Scientists, Ayub and McEwen again of 2003. And Accident Precursor Analysis and Management, Reducing Technological Risk Through Diligence, National Academy of Engineering, the National Academic Press, and Washington, D.C., 2004. So here I've only cited 6 textbooks or references. You can also opt for more, you check for more. Online, all the materials or textbooks are available. You can check it and you can study likewise. So that's all for this. We'll have 2 sessional exams, as you all know, and when in my subject I'll be giving a weekly assignment as the procedure was. So that's all. You can give your attendance now in the chat box. Thank you.